Welcome.
To the joy of coding.
Hello! And welcome to episode 403 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. Gonna be live hacking on some Firefoxy related stuff today. And let's get to it. Why delay? Let's get to it. So here's my screen and today's agenda. It's June 4th, 2025. It's June already. January, February, March, April, May, June. Holy cow, we're at the 6th month of the year. We're nearly halfway through the year. That is wild how time is flying. It's episode 403. A reminder, no plan survives breakfast. I think I know what I want to do today. I have kind of like a set of things I want to get through, but we'll see how it goes. You know, I'm live coding and live hacking, and so things might go wrong. We might get stuck, sidelined, distracted. Who knows? That's the first thing. The second thing is that the agenda that we're looking at, which has all these handy links that you may find relevant, is something you have access to. If you're watching this on Air Mozilla, check out the details section for a link to the agenda. If you're watching this on Twitch, it'll be down in the channel details. And if you're watching this on YouTube, it's down in the video description. I also want to plug the episode guide. There is an episode guide to The Joy of Coding. It's completely viewer-driven by people just like you. And if you want to add your own notes, addenda, corrections, etc. about a particular episode, maybe you saw something, I made a mistake, you want to sort of expand on what went wrong, or you want to maybe expand on something that went right, or something that happened, feel free to send a pull request to the repository. I'm very, very easygoing when it comes to pull requests to the repository. Anything that we can do to make the episode guide more useful to you as a viewer would be great. And no worries, Smurfy. I see Smurfy, what are prolific, I would say dominant contributor to the episode guide. No pressure. You have been such an amazing contributor to the episode guide that you should not feel under pressure to be like we gotta keep it up, keep up to date. I'm pretty relaxed. You should be relaxed too. All is well. All right, let's get into it. So what's going on today? Well, first of all, there were no questions sent in the form, but I did see this get sent to me over YouTube. Like this morning, I opened my phone, was like, "Hey, YouTube comment," and this message came in, and I don't really know what to make of it, but I thought I'd mention it. I'll read the message. Hello, Mike Conley Toronto. I'm leaving this comment today. Mike Conley Toronto is my YouTube handle. I'm leaving this comment today because I wanted to tell you something. I've been watching your videos for around 9 years to help with coding. Have I been doing it that long? 9 years? 9 years? 9 years. That is wild. I've been watching your videos for around 9 years to help with coding. So maybe they're watching this one right now. 9 years. Why would they break the habit? Through all your help, I've actually created a coding course and I've made a good amount of money that will surely help me over my life. I just wanted to say thank you, guiding my path to my 7-figure business model. Whoa, thank you so much. You're welcome. I'm glad. I mean, let's presume that this is sincere and serious and it's in good faith. So, wow, you're welcome. I'm so happy I could have had that kind of impact. Do good things, do good works. If you are making 7 figures, do good things with that money. And I hope you're having a good time. So there you go. The joy of coding. Not just like when I first started doing this, it was like there are a couple of reasons to do it. You know, the CEO of Moco at the time, Mitchell Baker, had challenged us to like find ways of being radically open. This was my way of doing that. And the other reason was so that on Wednesdays I'd have this like big block of time where I would be prevented from checking Twitter. And because like at the time I was like addicted to Twitter and I'd be checking my email. I was like, if I can like have a real excuse where I am systemically prevented from checking Twitter or my email, that I'd work on something. And there are obviously other technical solutions for doing that. I could just like block the domain. I could uninstall all these tools. I don't use Twitter anymore, but like at the time that was my intent, but also to try and be radically open. It was like a multi-pronged approach. The fact that if this is a thing that actually happened, if someone's like turned this into was able to take what I did in the stream and they've turned it into some kind of business coding course and they're making 7 figures. That's unintentional, but pretty interesting. And congratulations. Cool. All right. So last week we got some feedback on the Rust shared component we were writing. Let's take a look at that feedback. So this is the pull request that we sent. I haven't really read it since I saw that it came in like on the same day that we sent the pull request, but I haven't actually read the feedback myself. I thought I'd read it in front of you and react to it in real time, and so we can sort of like figure out what our next steps are. Okay, so I've got 2 comments in here. One is from Mark Hammond and the other one is from Ben. Both of these are the sort of the ostensible maintainers of application services. So these are the right people to be commenting. And the first thing that Mark mentions is that like these adult set, the hard-coded set of binary bits seems like a lot. I assume it's generated. Should we describe how it's generated? Also, not sure it makes sense here, but it might be useful. This might be useful as an alternative. This would mean the Rust code ends up getting a very long static string to parse at runtime, but the format of the string therefore becomes more flexible. So you could imagine each line has a single base64 entry or similar. Example, we use this to include .sql files. We don't actually parse them, but there is precedent in the tree here. Again, not exactly sure this. Not sure this is actually useful though. So this is mainly about the big old set of like this thing. Where's this big old file? It's probably being hidden. Yeah, hidden by default. Large diffs are not rendered by default, but this is the big conversion of the bytes that we were storing inside of the filter adult module before. I think this comes from import sitelist. Agreed that using include stir or maybe, so Ben is right. It does come from import sitelist. Agreed that using include stir or maybe even include bytes and not checking this as a source file would be better. Just typing in this GitHub comment box is painful. I don't think the parsing would be very hard. I think something like this would work. So we would import, instead of like having it be in the source tree as a as like text, we would have some kind of binary that we would write to. Adult set.bin. I don't know what include bytes is, but let's see. Chunks exact 16 hash set from chunks exact 16. That's interesting. Let's see what include bytes does. Rust include bytes. Macro includes a file as a reference to a byte array. The file is located relative to the current file. The provided path is interpreted in a platform-specific way at compile time. So, for instance, an invocation with a Windows path containing backslashes would not compile correctly on Unix. This macro will yield an expression of type such and such, which is the contents of the file. That's right. That sounds good. So it just gives us the bytes in line. That sounds fine to me. I don't mind that at all. And then fail. Is this ever raised? I'm not sure if it made this component would have no error handling. Could have no error handling at all. It's true. I don't think we ever actually raise errors in our module. I was just kind of like following the template example component. So we probably have some cruft we can remove. And then yeah, this is that other comment. So it seems like the vast majority of the feedback here is related not to the I'm getting a message in developers. Vendoring to run the mock commands. Vendoring. Okay, I will read this later. This is something I will have to look at later. Well, actually, you know what? This is interesting. So I have been messaged just now, a minute ago, inside of Matrix, and it's about someone who's attempting to vendor something into a bug. Let me open the bug separately, make sure it's not a security bug. Raptor not found. What the heck? Oh, something's wrong with the URL that I was given. So this is not a secure bug, so I can bring this over here. Remove pocket suggestions from the suggest component. Okay, and so one of my colleagues is working. So we have like this. We should remove pocket suggestions from the suggest component in application services. Pouring one out. I don't actually want to pour out this water on my lap or anything, or on the floor, but pouring one out for Pocket. I like Pocket, but we are end of lifing it. We are sunsetting Pocket, so we can focus on Firefox. We should remove Pocket suggestions from the suggest component in application services. So this is part of the decommissioning work to remove the integration from the Firefox clients. There's not a single place or module where they live, but this code search should cover everything. What? Okay. This is the corresponding desktop bug. Remove pocket suggestions. Once that's merged into app services, we'll need to vendor it into MC, which should have a separate bug filed for it. Vendoring steps. Update cargo toml so the application services component use the new revision. In a full non-artifact build, run these instructions. Vendoring docs 1.2. Upload the resulting patch to Fabricator like usual. And then the what we're dealing with is a question. I'm trying to follow the steps. A person's trying to do this. Reporter told me that, to run the mock commands listed in the bug for running the build. So I've done that, but I ran into another error when I got to running mock unified generate. This is the error message. Can I? No, I can't. How do I show you this? How do I show you this? I guess this is a public channel, so I'm gonna bring how copy image. Let's paste into preview. New from clipboard. Okay, so this is the error message. Linking with link failed. You may need to install Visual Studio C++. Linking could not compile CERD due to one previous error. Build failed. CERD. So CERD is link failed. Some arguments were omitted. Link extra operand. Try link help. Why did it fail? You may need to install Visual Studio Build Tools with the C++ Build Tools workload. Visual Studio Build Tools. I thought Mike is on Windows. I am not. I am on Mac OS. However, this looks interesting from the error message. So I'm just gonna highlight the. Can I like? I'd love to copy the text, but I can't. Oh, copy text. Thank you, Mac OS. So let's paste the text. What? Here we go. Copy text. There we go. Good thinking. Good job, preview. You can install Visual Studio Build Tools with the C++ Build Tools workload. Link extra operand. Try link help. Some arguments were omitted. Yeah. That's interesting. Can we also see what changes were made to cargo.toml? So there we go. I've asked the question, and now we will go back to when you say vendoring in. What does that mean? Oh, vendoring in. Great question. So Firefox has lots of code, is a bunch of code in it that is like not necessarily written by people from Mozilla. Like we have like third-party libraries, etc. So let me see if I can find where's the list? There's like the licensing list. This kind of helps sometimes about license. You can see some of the other things and other licenses that we're using. So for example, let's just pick a case here. libcubeb license. So under libcubeb, I guess this one's the they're using MPL. libevent, this license applies to this folder. We have like other pieces of software that are used to build Firefox, and when we vendor in, that means to like bring in from the external repositories or the external sources into the source tree, those third-party libraries and utilities. And that's an interesting thing. Like if you've ever run like npm install or pip install, you are like bringing in dependencies, and that's great. You don't want to reinvent the wheel. If other people have brought stuff in, or like if other people have written stuff and it's appropriately licensed, you can potentially use it and not reinvent the wheel. You can like stand on the shoulders of giants. But you have to be careful. I mean, these are opportunities for what are called supply chain attacks. So for example, there was this famous incident from back in the day, NPM. I think it was called the LeftPad incident. LeftPad incident. NPM LeftPad. So this is an NPM package where I believe it's very simple what it supplies. It's like it just offers a utility for adding padding to the left side of a string. You give it some string and I guess some length that you want the string to be, and then the character to pad with, and this is the module. That's what the module does, which is kind of, at the time it was like comical. It was like, why did we do that? And I believe there's actually an ability to do this that's built into JavaScript anyways. But I digress. That is not the point, is to criticize LeftPad itself. It's to highlight that this was actually weaponized a little bit, where someone took over this module. I don't exactly know how that was done. They published it, and then and then someone got access to it, and then there's some bad language in there. Published it, despite its relative obscurity, was heavily used, packages used as a dependency. And then like other things that are more critical were built on top of LeftPad. This included Babel, Webpack, React and React Native. Like you get this tree structure where you might not have it as a dependency directly, but one of your dependencies might have it somewhere within one of its dependencies, right? And if you're not careful, one of the dependencies further down the tree can get taken over. What happened? Several hours of the package. This wasn't compromised. It was deleted. They took the package down and broke just a ton of stuff because like the package went missing, and so like a bunch of stuff that was relying on it, and like it kind of broke things. This wasn't a supply chain attack. This was like a supply chain disruption. So like vendoring in, you kind of have to be really careful about it. One of the things that we do is we have a folder. We don't just like use the tooling to like locally when you're building, bring in those third-party sources. We actually bring them into the source code itself, and that's what we mean by vendoring. We vendor in. We like bring in the source code into the build. So if you go to under the source code of Mozilla Central or main, whatever you want to call it these days, and you go under third party, all of this is a bunch of stuff that we bring in that Mozilla didn't write necessarily, or is being brought in from a different location. So for example, we actually bring in some stuff from the Chromium browser. Some of their sandboxing technology, some of their IPC stuff we use. What else? WebRTC. We share the same WebRTC library as other browsers, as like the Blink browser, and that helps with the sort of interoperability, is because it's all running the same like client code under the hood. And then some of it's broken down into like different languages. Like these are a bunch of Python dependencies that we have vendored into the source code. And what that means is whenever you build, you're building what's in the source code. You're not just like assuming that you're going to go grabbing something out of a repository. Like we're not going to go grab left pad off of npm and build locally. We have it all vendored in, and it's like locked that way. And then we are very conscientious and we are very thoughtful about updates to what's vendored in, like upgrades, and we vet them. We vet them to avoid sorts of things like supply chain attacks. So there's a lot of a supply chain attack being like, imagine someone were to, let's say there's like a dependency of one of these libraries that someone is able to fool the package host, or they buy the rights to maintain the library, and then they go full evil and they like put a crypto miner or something inside the library. You need to be able to, you don't want that. You need to avoid that. And so this is how we do it. We vendor it into the repository, and it gets inspected, it gets reviewed. Everything that comes in gets reviewed and vetted. Right. So yeah, we share code with other projects. Like there's stuff in here. Why reinvent the wheel sometimes? Like what was another one? This is a codec, David. What else? We bring in some things from WebKit as well, it looks like. I didn't know that. Some performance testing stuff. Okay. What kind of stuff from Python in Python? Like the Rust stuff. This is a bunch of stuff we bring in from Rust, these modules. And so one of the things that we're attempting to write is something that will go under here. XZ is the famous one. That's the one I was thinking of. Thank you. Yes, this is a supply chain attack. XZ utils backdoor. Ooh, this is so interesting. This one is worth reading on vendoring. If you're not familiar with this is like a fascinating story of a really subtle supply chain attack that had like real world implications. I don't have I didn't do a deep dive into the XZ thing, but imagine, if you will, that inside most locks to every door, this is like a metaphor or an analogy. Imagine that every lock for every door and for every car, there was a key that could bypass all of them, that would work for all of them. And one person, they like infiltrated the lock manufacturing, not the lock, the places that build locks, and they'd snuck in a little instruction by way of like very, very methodical, slow, sneaky supply chain attack, and taking advantage of like an exhausted source code maintainer who, I guess, just, they didn't pay attention. They should have, like, it was very subtle, but basically now they made it so that lots of doors can be opened with like a special key that one person has, or one institute. We don't know if it's a person, it's a state actor. I don't think it's been cleared who this attacker is, whether or not it's a state actor or it was a single person. And how it was discovered was by like performance analysis, I think. This could have been the most widespread and effective backdoor ever planted in any software product. It would have given its creators a master key to any of the hundreds of millions of computers around the world that run SSH. If you are very interested, if you're interested, I highly recommend reading about this, because it is fascinating how it was done and how the attack worked and how it was brought into the source code. So if you are a reviewer of a package, of anything that other people depend on, it is, and this is especially true now because like AI tools are generating so many pull requests that there's just so much noise that you have to be careful. Remember, you need to review everything that comes in, and assume that someone is trying to, no matter where it says the patch is coming from, assume hostile, and look for that with a very critical lens. Okay, so where am I? I'm way off track here. We were talking about vendoring. Oh yeah, I was answering the question. What does vendoring mean? Right. So what we want to do, it sounds like what Mark is suggesting we do is instead of generating this adult set.rs file, is that we're going to generate something that gets read in from this binary file. Fine. And then we can read the hash set from chunks exact 16. So we need to be able to write the bytes using our import tool. Let's go back to the filter adult repository. Here, let me pump up the font here. Pump up the font. Application services, which we're on filter adult. Okay, great. We are going to understand how to write the file that we will include as this .bin. That is the key. So basically we need to like figure out how to update import site list to, instead of writing this static Rust file, we're going to like that exposes this list of this adult set static array. We're just gonna export the bytes, I guess. So that's interesting. How do we do that? So how do we chunks exact? That is the thing that's going to ingest this stuff. Let's see if we can read more about that. Standard, what is that? Standard slice. Adult set is bytes. What does include bytes return? So let's get all of this information. Include bytes. What does it return? Yield an expression, a series of bytes, statically allocated at build time, which is fine. How do we write the bytes? Here, let me close some of these. And then standard slice chunks exact. Returns an iterator over chunk size elements of the slice at a time, starting at the beginning of the slice. Okay, so bytes. The bytes are going to come in chunks of 16, is what Ben is suggesting. And for each one, we're going to insert them into the hash set. Okay, makes sense. That's basically what we were doing before. So let's see here. Rust write bytes. Perfect. Similar to C's memset, but behavior isn't defined. So how do we write? Because like what import site list does, we bring in, we ingest it, we insert into this hash map, which I don't think we're going to need the hash map anymore. The hash map was really only interesting because we wanted to map the bytes to the thing that generated the bytes, which was the sort of the string representation, the base64 encoded MD5. We're not going to have that anymore in this set of bytes, so we don't need a hash map anymore. So what we need to do is we're going to take a set, and we're going to a set of bytes, a set of 16 byte slices, and we are going to try and basically serialize them. So how do we do that? So Rust write bytes from hash set. Converting vector of bytes to a hash set. I need to write, I guess maybe it's sufficient to just because we just need to like create a giant slice, a giant vector that we're just going to be appending 16 bytes, 16 bytes, 16 bytes, and then blast that to disk. Write bytes dot bin. How to write 16 bytes. So here, this person has like a vector, and then what they do is file write all, but they use this unsafe thing. Ooh. File write all. What is that? Write all, write all. Attempts to write an entire buffer into this writer. This method will continuously call write till there's no more data to be written or an error of non-error kind interrupted kind is returned. This method will not return until the entire buffer has been successfully written. Okay. If the buffer contains no data, this will never call write. So this is exactly what we want. This is exactly what we want. So what we'll do, we can, instead of creating this hash map here, we're going to update this to return a vector of vectors, I guess. Buffer write. Or a vector of bytes, really. We're just going to keep adding to the vector. So I think this is it. It's not a vector of vectors, it's a single vector. And vec. Let mute result equals vec new. And we're not going to, oh yeah, we're going to, for each, what is this doing? This regex was used to go through each one. Captures it or filter the contents. For each one, we'll extract it. We're going to decode and get the byte hash. And then instead of inserting it with the string hash to string, because I guess we don't need that anymore. We don't need to capture this. Oh, we do need to capture it. That's what we're decoding. Okay. But we don't need to insert it. What we're going to do is we're going to a vector. Rust vector. What's the definition of vector? I want to moves all the elements of other into self, leaving other empty. That sounds right. I want to move. We're going to result dot append, and then we're going to insert byte hash, and then we'll return result. And then after ingesting the MJS file, this is no longer a hash map, this is bytes. Generate adult set. We don't need this anymore. We need to write the bytes. So this was outputting to standard out. I think what we want to do is accept a path to output the output file now. Output file. The path to write the adult set.bin file, which are the bytes generated, which are the bytes for the hash set that that filter adult will hash set of adult sites. All right. Cool. A tool for generating adult set.bin from the pre-existing filter adult. The result is not sent to standard out. And so instead of printing it and instead of generating it, we are going to write these bytes. So how do you write bytes? I think we saw this before. Writer, write all. So let mute buffer equal create, and then we're going to pass it CLI.output file as dref unwrap oh wait, string has read to string path unwrap or else. I think what I want is file create. What is Rust file create? Accepts a string, a path, a slice of a path akin to stir. Okay, a reference to a path. So we should already have one. So let output path equal, I'm going to call this input path, and unwrap and I'm looking for like expect, or how do we, as dref another write the bytes, another one writes the bytes, says Danny Colon. I don't know what you mean. Rust as dref, so it's an option as dref. Okay. Unwrap as dref question mark. Expect. Panic. How do I do it without the question mark? Maybe it's fine. Maybe it's fine. File create output path. File create. deal with it going wrong? Expect. Right. Dot expect. Unable to write. Output path dot display. Just move this into here. Don't need that. Now, assuming we have that buffer, write all some bytes. Buffer dot write all bytes. Done. Now these tests are, what are we going to do now? Well, I guess we can ensure that expected hashes vec for hash. So expected hashes, and then so instead of getting a hash map, ingest will take the string and it will give us back a vector, and then we're going to do what Ben suggested, and then get a hash set. Let hash set, what do we call this before? Hash map. I say let hash set equals bytes chunks exact 16, and then ensure we got the expected number of hashes out. Yes, and then for hash and expected hashes, look at the bytes. We'll ensure that a hash set contains and it just returns assert not equal, assert true. Is that how you do it? Rust assert true. Is it just assert? Yeah, okay, assert. Contains. And if it's empty, we'll say that the bytes and then we'll get the bytes out, and then assert that the hash set length is 0. Let's see if that passes. Cargo. Let's see here. C components filter adult cargo test. Already it is not happy. I'm missing, there's an unclosed delimiter. So something about my syntax is wrong here. Expect. Oh, missing it. All right, missing a bracket. Failed. Use of undeclared type file. Consider importing one of these structs. Let's get standard file. That sounds important. Standard fs file. I guess I was using fs before. I could do read to string and file. And then we don't need the namespace anymore. Let's see what it thinks of that. It doesn't know what a hash set is. Hash set. Using standard collections hash set. Do you still have hash map? Nope. Okay, let's see what that thinks about it. Okay. Getting closer. Hash map not found in the scope. Line 111. Did I... Oh, whoops. Whoopsie daisy. Hash set. Okay, getting closer, I think. Expected stir. Found string. This error originates in format. It expects a stir and found a string. Expect so most people don't do expect format. Ampersand format. That is common, more common. Okay. Does that make you happy? And then no method named write all found on the file struct. What? I thought you were cool. Provided methods. Write all is on standard IO on the write trait. File create on standard FS file. Did I do this wrong? Write all on buffer. Buffer. Oh, what do I think? What does it think? The method is available for file here. Write, which provides write all, is implemented but not in scope. Perhaps I meant to import it. Oh, you're so helpful. You're so helpful, Rust. Standard IO. GPHI. Write IO write. Expected. Okay. Found a vector, not a list of bytes. But consider borrowing it, because then you get then you can do that. All right. Okay, better, closer. Expected mute vec found vec u8 in line 50. Expected mute vec found vec 8. Expected found struct. Method defined here. Append. Consider mutably borrowing. Okay. Sure. Is it going to be happy with it if I'm mutably borrowing? Warning or error. The trait bound such and such is not satisfied. The trait from chunks exact is not implemented for hash set. From is implemented in hash set random state. For that trait implementation, found chunks exact. Oh boy. Is not the trait bound such and such is not satisfied. The trait from chunks exact is not implemented for hash set. But it is for random state. But I'm Is this cannot borrow is mutable. Consider changing this to be mutable. Let mute. Okay. So we're down to this. We're down to this, and I don't know what it's trying to tell me. Let's see if we can find some examples of using chunks exact. Anyone using a hash set? No. Hash set from chunks exact. Rust. trait implementations from random state. It's the default state for hash map types. A particular instance random state will create the same instances of hasher. So if we hash map with hasher S for a random state, create the same instances of hasher, but with the hashes created by two different random state instances are unlikely to produce the same result for the same values. Okay. With hasher, hash set with hasher random state default, and then is there like from Rust with hasher from bytes hash set. Rust import bytes into hash set. Bytes. Your serialization is incorrect as it tries to collect evacuate from an array unit. Instead, fully extend vector over slices. Chunks. So for each byte, whoops. Say line 101. Here. For each byte, as bytes. Bytes. If I is it like what do I do here? It seems like the recommendation I got to use from adult set chunks exact 16 doesn't work. This construct doesn't appear to work. Do we ever use chunks exact on a hash set? Vec with capacity. Hashes bytes length. Hashes equals a vector. Hashes push. Hash in hash bytes. We construct. Okay, so like for chunk in bytes, chunks exact 16. Let hash set equal hash set new. Mute, and then hash set insert chunk. What do you think of that? No borrowing required. Hash set contains the borrow is not implemented for Insert 117 down here. The trait borrow is not implemented. Required by bound hash that contains. Required by a bound. The trait borrow is not implemented for reference U8. Required by a bound introduced by this call. The trait is not satisfied. What do you mean? What do you mean? Let's what happens if I don't do that? That's also what happens if I don't do any of this. Let's just get rid of this for now. What? Okay. Okay. So it's really just this assert that the hash set, checking that it contains the hash. Do I have to let it borrow it? It's not implemented for U8 required. The hash set insert. Do I borrow the chunk? I feel like I'm thrashing here. I can't just, so for hash bytes. Oh. I need to be checking to see if it contains the hash bytes. Not the hash. I need to check if the hash bytes. Okay, now this is more like it. Contains hash bytes. Someone asks, what does the 16 mean? Is it 16th entry in the array? That's this here. I think what it means is our MD5, our MD5 representation is an MD5 hash is 16 bytes. And what we've done is we blasted all of those MD5s into this binary file. And then we want to extract from this binary file, but we're telling it, hey, slice it every 16 bytes. That's one, that's another one, that's another one. It should divide evenly by 16. Each one represents an individual entry. And that's what we're going to iterate over. That's what it means. Okay. So I feel like we're almost there. Trait is not implemented. This is 117. Not implemented for U8, required by bound. We're almost there. Borrow is not implemented. And if I do it this way, not quite. Expected ampersand, found vec U8. But if I add what it wants, then it complains that borrowing, the hash set expects to be able to borrow. Expected hashes is a vector. Borrow. Is this something I can Google? So hash bytes, we decode, compute the byte representation of the hash, ensure it is what the string hash has been mapped to. Compute the byte representation of the hash. We expect these bytes in the set. Base64 decode is going to give us VecU8, and we can't borrow. Can we clone? Anyone know what's going on here? Any help? Hash set contains needs to be able to borrow. I don't know what you mean. Let's look at instances of using contains. Hash set contains. Contains. Here they're doing assert equals true. That can't be it, right? This couldn't possibly. Yeah. These are literals that it's passing in, literal numbers. The value may be any borrowed type, borrowed form of the set's value type. So one needs to be able to borrow but I can't borrow U8. Base64 standard. Rust. Decode. What does it give me? Decode returns a VecU8 and code returns a string. I need to but I'm hash bytes. If I pass that as a slice, that's why it's complaining. If I don't pass it as a slice, it's expecting a slice. Borrowable slice Rust. Can I borrow a slice from a custom type? Slices. We create a slice. A slice gives you a view into a larger collection. Slices borrow data from the sliced type. So get slice from vector Rust. How do I get a slice of a vector? The section titled slicing. A vec can be mutable. Slices are read-only objects. To get a slice, use ampersand. Borrowable. Borrow. Borrow. I want to borrow. Immutably borrows from an owned value. S. Borrow. This is a vec 8, not like. There's no way. There's no way. The method is available for vec 8 here. No method named borrow found for struct in the current scope. The method is available for vec 8 here in. Do I have to like bring this? Oh, jeez. No way. No way. No way. No way. This seems so weird. What is happening? Line 116 now. This feels wrong. I don't know what's happening, but all of this feels wrong. What I'm trying to do should be really, really simple. A type annotation is needed. Cannot infer type of the type parameter. Multiple implementations satisfying U8 borrow found. Acquired by. Contains. : dot contains. Okay, and then I tell it the type. The hash set is chunks. It's their U8s. What's their way of representing? Yeah, U8. Like that. And then, so that, now it's complaining about this. So if I get rid of this test, does this pass? That's crazy. I am not pleased about this. What is happening here? Why do I need this weird construction? This seems very strange. All right. Maybe my reviewers can help me out here. So we're going to do the exact same thing down here for chunk in bytes, chunks exact. Well, I think we just say that like assert that the bytes length is 0. Yeah, there we go. Didn't you have to use contains hash bytes? Contains dot contains hash bytes. I'm certain we tried that. Let's see. Contains hash bytes. Yeah, not happy. I don't know. Help me, Elpoxo. Help me, literally anyone who knows this stuff. Okay, so not thrilled about that. But we now have this thing that apparently generates our bytes. I also don't know this stuff, Elpoxo. I'm very new to Rust. And I'm hoping my reviewers can help me figure out what the heck is happening here. But now I can use this. I'll use the command, not mock, sorry. It's cargo run bin import site list help. Input file. Input file is projects Firefox. Browser modules filter adult. Output file is source adult set.bin. So did it work? There's an adult set.bin. Let's it is some bytes. Okie dokie. Let us now change adult. Oh, okay. So we'll do JJ track file track source adult set.bin JJ file untrack source adult set.rs. We're going to remove source adult set.rs. That's going to make it so that lib no longer builds. So we don't need the pub mod anymore, or this. And instead, on construction, we're going to import bytes, include bytes. Let adult set bytes equals include bytes. And then what did we do inside of import site list in our test? We're going to chunks exact and insert it into our set. Let mute hashes equals hash set new for chunk in adult set bytes chunks exact 16, and then we're going to return self. That's what we'll do. And does that build? A local variable with a similar name exists. 47 hash set. Oh, hashes. Hash set insert along 47. What? Cannot find. Oh, I'm reading the wrong error message. Hashes insert chunk. The argument has type at U8, which causes the hashes to have type hash set U8, but it's supposed to be hash set U8 16. Insert as type at U8. It's a slice. So what I'm inserting are the slices. Can I chunk.clone? This argument has type U. It's a slice still. And I need to have this slice become an actual vector. Turn slice into vector. To vec. Is that it? To vec. What? Vector versus list in Rust? Like, what is the... Oh, it's an array versus array. An array's data can live on the stack, while vex data always goes to the heap. Okay, so then I want slice into array, Rust, convert slice. How do we get a slice as an array? Try into trait. Try into barrier for try into or clone into array. Mute default as mute clone from slice. Mute array. I can also for p and iterate zip. copy from slice. Copy. Is this? $16. Copy from slice. Chunk. Insert. What do you think of that? Fine. I don't like this. Why is that different from the test? How we were doing it before? Is it because the hash set that we were generating before didn't have an exact type? It didn't have an exact type. Maybe it should. All right, well, let's run the tests. Cargo test. All right. I read the docs and now wonder if contains hash bytes iter would have done it. Let's find out. Let's find out. We still have time. Let's here's the test. So here's our weird construction. Assert equal hash set dot contains hash bytes dot iter true. I'm starting to go down a weird path again. So no, that did not fix it. I don't know what to do. Now the good news is we've got our bin file here, and it's full of binary garbage. Cool. But our tests work, and now the other piece of feedback was the errors failed to construct in error.rs. Yeah, I don't know if API error, other pub enum error. There's no. It's never thrown. So I don't know if we need, like, the API other derive this error, unify error. I don't know if we need this part. Let's see what happens if we don't do this. Unused imports and unresolved import, because I don't think it's used. Not found in scope. Use standard error. Handle error in lib24. What were we doing over here? Use standard error? Why not? The unused import, I've expected type found a trait. Oh, jeez. Maybe that wasn't the right move. It wants handle error, but there are no errors. So maybe we just get rid of these, because there's no error. And then filter adult error.rs. Doesn't know what I mean on line 7. Result. Result. Expected 2 generic arguments. We supplied 1. Okay. And And then unused imports here on line 5. We're going to get rid of these. And then it's complaining on line 25. The trait from now implemented for API error. Inner. Filter adult. Inner new. Unwrap. Okay. Unused result that must be used. Line 39. 39. With buffer write all on, sorry, in import site list. 39, the result is not used. Expect format. Writing bytes failed. Maybe I'll just do that. Writing bytes failed. Cargo Clippy. I'm expecting a lot of feedback on my patch here. I've done a bunch of weird stuff. Wait. Unused import hash set. Are you sure we're not using hash set? Oh, we are using it. We're not using it except in the test. And then unused import borrow. Unwrap or else panic. Unable to try. Okay. I like the cut of your jib with that suggestion. Expect. Okay. Cargo format. Cargo build. Cargo test. All right. Yeah, this is very strange. I don't know. I'm expecting the experts who understand what's going on here with Rust to sort of help me figure out what the heck's happening. But I have applied the review feedback. I have made changes. We've gotten rid of our big binary. And then we updated our tooling. We changed how importing works. We updated the tests. And then we got rid of the error. So I'm going to go ahead and commit JJ squash. And then I'm going to go JJ git push. And we'll see what they say. For some reason, it wouldn't accept hash set from adult set chunks exact. So I had to iterate the chunks and insert them manually. Yes, I can turn this into adult set.bin. That's no problem. I got rid of the unused errors. Okay. Resolve. I'm gonna re-request review. And we'll see. We'll see what they think. Today I learned about JJ. Oh, Alpaxo. I cannot recommend it more. I love jujitsu. I actually did episode 3. What was it? Episode 397. I started to do a deep dive into jujitsu, and I am a convert. I'm so much better than raw Git. I much prefer it to using Git, especially coming from someone who was more used to the mercurial world. I love jujitsu, and I can't wait until I don't ever have to think about Git ever again. All right, so we did it. We only did this. We didn't do these other 2 things because we were just dealing with compile time issues. But hey, that's what happens. Hey, thanks so much for watching episode 403 of The Joy of Coding. I wonder what will happen with episode 404. Future me. There's a joke to be made here. Thanks again for watching. Let me know what you thought. There's a rate this episode link here in the forum. I'm going to go ahead and drop that into the chat. Rate this episode forum. Feel free to let me know what you thought of the episode, what I could do more of, what should do less of. Tell me if you're making 7 figures because of my stream. I don't necessarily want to cut, but tell me if you're just making bank from all the stuff you've learned from me. That makes me feel good that people are actually making use of the stream, that it's making some kind of impact on your life. And if you're making 7 figures, do good in the world. And with that, I'll call it there. Thanks again, everybody. Have yourselves a great week. I'll see you next week. Take care. Bye-bye.
The joy of coding.
See ya.